Hi everyone! In this video, we're going to look at similarities in right triangles. And as you look here at this triangle, we actually have one large right triangle, but then inside that large right triangle, we have two other right triangles. Let me outline those. So the one large right triangle is right here outlined in red. And then I have what I'll call the medium triangle that I'm going to outline here in blue. And then I have a small right triangle that I'm going to outline here in green. So those are my three triangles. Now I'm actually going to replicate these three triangles and stand them upright. So here's the one large right triangle. Here's the medium right triangle in blue. And then here's the little right triangle in green. Now to help me draw them on the right, I am going to mark this angle with two swoops, the double swoop. And I'm going to do the same thing with this top angle. And in fact, this is the way that I always set up similar right triangles. Then down here in the large right triangle, I'm going to put a single swoop. And same thing down here, single swoop, and single swoop. Okay, now it's time to label these right triangles off to the right. Now what's important to note is that these three triangles are similar right triangles, meaning they all have the same three angle measures. All right, let's look at the large red right triangle. See if we can label any of these sides. Well, the side between the right angle and the double swoop of the large red triangle would be right here. That's not labeled as anything, so we're going to leave that blank. The same thing between the right angle and the single swoop. That's not labeled as anything, so we're going to leave this blank. But the hypotenuse of the big red right triangle you can see is right here, across from the right angle, and that is made up of x plus 8. So we're going to label this as x plus 8. Now to look at the medium right triangle outlined in blue. You can see that for the blue right triangle, there's a double swoop and a single swoop. So right here, here's our right angle of our blue triangle. Here's our double swoop, which means up here in the top right, this must be a single swoop right there. All right, so we can see the side between the right angle and the single swoop of the blue triangle has a length of 24. So let's label that down here. Then the side between the right angle and the double swoop of the blue triangle is x. So we can label that there. Now on to the small green triangle. Why do I stop there? Because the hypotenuse of the blue triangle, or the side across from the right angle of the blue triangle, is not labeled. So now onto the green small triangle. You can see here's the right angle. Here's the single swoop. So up here must be the double swoop of the small green triangle. The side between the right angle and the double swoop is 24. So let's label that over here. And the side between the right angle and the single swoop is 8, so I can label that down here. There are your three similar triangles. So in order to solve for x, what we will need to do is we will need to set up a proportion, because we know similar triangles are proportional. So in order to solve for x and set up my proportion, I need to set up the same side divided by the same side. Here, I only have a hypotenuse of the large triangle, so in fact, I am not even going to use this triangle. I'm going to go over here, and I'm going to divide the long leg of the blue divided by the long leg of the green, and then the short leg of the blue divided by the short leg of the green. Okay, so to set up that proportion, it would look like this. The long leg of the blue triangle divided by the long leg of the small triangle would equal the short leg of the medium triangle divided by the short leg of the green triangle. Now to solve this, we would cross multiply. So multiplying across this way, we have 8x. Multiplying across this way, we have 24 times 24, which is 576. Dividing both sides by 8, we can solve for x, and we get 72 And that's how you would set up your 3 similar triangles. Let's look at one more example. And if you're finding this video useful, make sure to click subscribe in the lower right so that you're notified when new videos come out that'll help you in your math classes. In this triangle, I have already gotten the 3 similar triangles set up here, but I'm going to still outline them. Here is my large red right triangle. Let's label this as the double swoop, and this is the single swoop. Let's do the same thing over here. Double swoops there, and single swoops here. Now, let's label the sides of the big red right triangle that we know. Between the right angle and the double swoop, that would be a length of x, right here. Between the right angle and the single swoop, we do not have that, so let's leave that unlabeled. And then the hypotenuse, which is the side across from the right angle, that is going to have a length of 4. We can label that here. Now for the medium triangle, which is right here in blue, here's the right angle. Here's the double swoop, so this one must be the single swoop. In between the right angle and the double swoop has a length of 3. That would be here. And then across from the right angle, the hypotenuse we can see is labeled as x. And this side we don't know between the right angle and the single swoop, so we'll leave this side blank for right now. And then finally, the small right triangle would be here. Here's my right angle. Since that's a single swoop, this must be a double swoop. And let's see, what do we know? We don't know the hypotenuse. We don't know the side between the right angle and the double swoop. The side between the right angle and the single swoop, that must be 1 if this whole side length is 4, and we already know that that side is 3. So I can label that side, but that's about it. Now in order to set up my proportion here, it looks like I'm not going to use the small triangle because I only have one side. So for my proportion, in this one, I'm going to set like sides are going to be set up in the proportion. So long leg of the big triangle divided by long leg of the medium triangle. So that would be x divided by 3 equals hypotenuse of the big triangle divided by hypotenuse of the medium triangle. So 4 over x. Okay, to solve this, let's cross multiply. X times x would be x squared. 3 times 4 would be 12. And then taking the square root, we would have the square root of 12. Now this radical can actually be simplified. Make sure to click right here in the upper right-hand corner if you need a review of how to simplify radicals. Watch this video. But this side would simplify to 2 square root 3. And that would be how to solve for x by setting up 3 similar right triangles. I hope you found this video useful. If you did, make sure to click subscribe so that you're notified when new videos come out. Thank you for watching.